So in this video, we're going to dive deeper into generic formulas. I'm going to repeat what was in the previous lesson, and then we're going to go a little further with what happens if you have more than one double bond, or you could extend this to more than one triple bond. So all members of the alkane family are going to follow the pattern CN, and N is the number of carbons. H count is going to be double the carbon plus 2. Okay? The plus 2 is coming from the fact that there's an extra hydrogen at each end of the molecule. There's two H's all the way through the middle carbons and an extra one at each end. Okay? Every time you add another bond between two carbons, so a triple bond, a double bond, or a third bond to get a triple, you're going to get the following patterns. I do want to highlight that when I talk about the generic formula for alkenes and alkynes, we're talking about one double bond or one triple bond. Okay? So when you have just one double bond in an alkene, you're going to have CNH. The addition of that double bond is going to remove a hydrogen from each side of that double bond. So in total, adding a double always removes two H's. So if I take 2 off the pattern above, I'm left with just 2N. With a triple bond, you've just removed another 2 H's to add the third bond. So if I take another 2 off, we have 2N, and then I have to go minus 2. And that's our generic formulas to really quickly get the hydrogen count without drawing a molecule out. That's going to be very advantageous. So I'm going to draw pentane, and I'm not going to draw it, I'm just going to get the formula for pentane without doing any drawing. So this is going to be C. I have to decode what the pent part means. And our pent is going to tell us that there are 5 carbons. No need to draw it. So I can very quickly predict the hydrogen count. I look at the family. It's an alkane. So I have to double it plus 2. So 5 doubled to 10 plus 2, there's going to be 12 hydrogen. Okay? And this is really useful for answering questions, particularly on the topic of isomers. You want to compare two molecules and know if they have the same count. You don't actually need to count them out. You just need the carbon count and the family. Next, I'll do pent-1-ene. Exact same strategies. What is the stem? Sometimes called the parent. This is pent again, so we have another C5. I want to predict the hydrogen count. I notice the family is an ene. I don't care the fact that it's a 1-ene. The position of the double bond has no bearing on the hydrogen count. So we've got a double bond, double the 5, and that's it. So we're going to have C5H10. And that's what our notes have gone through already. We're going to take a look at something beyond what the previous lessons had, pent-1,2-diene. We haven't seen a prefix in front of the ene yet, but the prefix just means there's more than one double bond. So di means 2. Okay? And there's 2 numbers, one to represent where both double bonds are. Okay? I can't use this alkene generic formula because it only works for one double bond. Okay? But we can very easily modify it, and that's the point of this example. So pent, C5, once again, same as all the other examples. H, if we looked at the very sort of beginning or the saturated hydrocarbon, the most hydrogen it could have would be double plus 2, so that would be 12. Okay? Every time we put in a second or third bond, we just take 2 away. So the first double bond would drop this down to 10, but we have 2 double bonds, so I have to take away another 2, and we're down to 8. So even though you don't have formulas for 2 double bonds, or what if you had a double and a triple, or what if you had 3 double bonds, okay? It's very easy to deduce what the formula would be by just taking 2 hydrogen off. So hopefully this is useful for for dealing with more complicated questions, both in high school curriculum or past high school in your post-secondary college or university course.